Hey there, so today I decided to do the problem of the Tarzan, or I guess the bunch of idiots swinging from this rope. So I started off trying to find the velocity when they were at this 42-degree angle, and to do that I used some energy. So we have here that the gravitational energy is equal to the kinetic energy. So mgh equals 1/2 mv squared, and I solved that out with all the numbers to get that velocity is equal to 28.05 meters per second, and that makes a little bit of sense, so I'm alright with that. And then the next step I wanted to find is I wanted to split the gravitational force into two components. You have the perpendicular component and the parallel component, and I did this because it would help me along my journey to solve what Ft is, and the perpendicular forces and the parallel forces. So I split this up by using the perpendicular line, which is 42 degrees from vertical, and I got that because that's 42 degrees, should be anyway, right there, and that's the perpendicular line, so that checks out. And I split into components, having here that F parallel is equal to mg sine 48, which is 2,913.1 newtons, and then F perpendicular is equal to mg cosine 48, which is just this one right here, and that's 2,623 newtons. And now that I have the velocity and the perpendicular gravitational force, I'm set to try to solve this little problem. So I set it up right here. mv squared over r is equal to ft plus or minus Fg perpendicular. And that basically means that the total force right here is this F net in general, the circular motion, F net, that's equal to force of tension plus or minus the force of gravity. So that makes sense conceptually. And I plugged in some numbers, got it. The total F net should be 5,245.35, and then the gravity is contributing that. We got that earlier. So then you add those together, because you know that Ft is fighting off some of the Fg to get this, and then you get that the Ft component for perpendicular is 7,868.4 newtons, which makes a lot of sense. Now I checked back to the Tarzan problem in our book a little bit during this, and it does check out because the Tarzan problem is with much smaller units, but it seems that if you were to multiply the units by that much, which is what we have, that it would be about the same. And then for F parallel, it's much simpler. We know that the only thing that could possibly be affecting it is the Fg parallel, because the tension isn't really going that way, so we don't have to worry about that. So that's just simply 2,913.1 newtons. And then you have right here your Fd perpendicular and your parallel force, and that's really all you need.